Hello, my name is Konstantin and I work at Facebook. So for quite a while I was working as a JavaScript developer, doing stuff on the front end, building websites with Angular, doing some stuff on the back end, doing Node.js, Webpack, Gulp, Grunt, all the fun stuff. About a year ago I joined Facebook and React Native team. And I checked just recently, I'm actually in the top 10 contributors in the GitHub. Well, I actually check it every day, so woohoo! Well, if you look at some of the comments, especially recently, it's mostly about reverted this thing, fixed those tests, something got broken, so I jump into it and fix the feature, or maybe ping a guy or a girl who committed something that broke other people. That is what is driving me about unblocking other people and allowing them to contribute to the project, not only inside Facebook, but from the outside. But enough about me, let's talk about who is in the audience. Anyone here worked with JavaScript? Yay! Anyone knows about React Native? Nice. Anyone worked with Node.js? And now, honestly, any one of you checked in Node modules into GitHub? Nice. I mean, sorry. Yeah, good. So because not everyone raised their hands about Node.js, let me remind a little bit. Node.js is an environment to run JavaScript on the server. And it comes with NPM, which is actually a package registry for Node and other languages. And the installer of Node comes with the client side of NPM so that you could install the packages easily. And quite recently, NPM rose so high and so fast that it has more packages than all the other package registries combined. And I was wondering why NPM is so successful. Is it because JavaScript became so popular? Or did JavaScript become popular because of NPM? And well, the first thing, it's easy to publish. Some people think it's too easy to publish, so we got a lot of simple packages that probably shouldn't be there. And by easy, I mean you just type a key, type something on the keyboard, press enter, and in just a few seconds the package is up there. And the other thing is how it resolves the dependencies. It's quite unique to many client-side package managers and many server-side. So let's look at the example. We have application A that depends on dependency B, and it depends on dependency C. In Java, for example, you just download them all, combine them, link them together, and you have an application. Everything is fine. Except when you start relying on dependency C of different version in your application. You basically have a conflict between C and C2. In Gradle, for example, you just have to choose one of them. It forces you and doesn't allow you to proceed without making the choice. Sometimes they are incompatible, and it is even worse. You cannot just choose. The application will not compile. What Node.js did is it said it doesn't really matter. In this example, the packages in Node.js and NPM were installed for application A, and they were extracted in Node modules folder. The dependencies of A are directly under Node modules, B and C2 here, but B has its own version of dependency C. This way, when B works with its code and it requires something from library C, it doesn't interfere, it just goes inside. And that's quite nice. I mean, you don't need to care about dependency resolution ever. Isn't it amazing? Well, the problem is that C can be 4 times in your application, sometimes 20, sometimes 200. And something comes to mind. When you have so many files, you actually have to manage them. It's not that easy. There are some ways to make your application less stable if you have many files in some of the areas of it. Let's look again at our application graph we have here. So in Node.js, in NPM, it's usually described with a package.json file. You have the name and you have the dependencies, B and C. Quite often, people set a loose dependency in the identifier to the version, so that if the community pushes a patch, it will be automatically sucked into your application. And as you notice here, we only list the direct dependencies, not the sub-dependencies. And the problem comes when you install something on your dev machine or on your test server and test your application all through. Here was the B3 dependency. Everything was fine, but then you deploy to production and you build a production build. And at that moment, the new dependency got resolved. B was patched by the community, and because of the loose versioning, it catches the one that is the most latest and the best thing. But this is something you may not expect. Things may break. Things break quite often. And even worse, sometimes a dependency, a package can be removed from the registry, or it cannot be accessible because there is a network partition while you were installing. And this is not something that you want while you are developing some business critical applications. And this is the problem that we faced at Facebook. So there are two problems that I just highlighted. First of all, node modules get bigger and bigger. And second, same package.json installation can result in different applications, slightly different because of the dependencies, either not available or change over time. And there are ways to make it more stable. And there are some things that companies and people in the Node.js community are using to make something predictable with their application development cycle. And I'll go through them. First of all, the thing called shrink wrapping. So you have your package.json, as I showed you before, on the same dependency graph in our application A. But instead of using package.json for your installation, you generate a shrink wrap. Shrink wrap is the same as package.json, but the difference is that you list all the dependencies deep in the tree, and also you freeze them. You don't allow them to be updated. All the dependencies are resolved to exact URLs of the target files that get downloaded from remote, unzipped, and then when it works. The only problem is, with shrink wrapping, you are still not protected from a dependency being removed from the registry. Or again, if network is not available. This is not something that we want on our build server to depend on a network connection. Or, for example, like yesterday's DDoS attack on the dependency resolution on the DNS. The second thing, so shrink wrapping is actually very good. Everyone should use it in the applications. But this is not that guarantees us to have a nice, stable build system. The other thing that was recommended for quite a long is checking in node modules. It was quite good when node community and NPM community were growing and applications were small. But once they got bigger, people started committing and people started noticing problems. Here is an example. So we have an application, which is a Node.js, and we have a dependency there called shell.js. It's a small library. I decided to update it from version 0.6 to 0.7. Should be a minor patch, right? Well, it resulted in a pull request with 228 files changed. If we check in those node modules, and if we check in every dependency, reviewing this PR is quite hard. And the second thing, there are too many files. And it's not just too many, oh, it's so hard. No, actually, at Facebook, we have a large repository. It's very convenient for us to have all the applications in the same repository so that they share the libraries, so that there is no dependency hell, at least inside Facebook. So it means that we have a special dedicated team that reviews and works with the version control systems and makes sure they're as fast as possible. So at some point, when we were committing node modules of React Native into the repository, because it's the easiest and the most reliable way to freeze your dependencies and not depend on the network, we were committing 100,000 files. And that is comparable to the whole size of the Facebook repository. And imagine every week we update 1 or 2 versions and there are 200,000 file changes. At some point, the version control team started knocking on our door and saying, hey guys, you're actually slowing down everyone at company because when they're rebasing, they're updating thousands of files at a time. And you need to do something about it. Another question people sometimes ask, all right, remember the shrink wrap and it depends on the targzip files? What if we don't check in the node modules with the 100,000 files? Or now it's actually a bit smaller. We tried to shrink the size a little bit. But just the zip files, because apparently they are quite small. Most of them are less than 30 kilobytes, and people are quite comfortable to having them checked in. And another thing, there is just under 1,000 of them compared to 50, 100,000 of them exploded. So is it a good idea? Can we do that? So Adios Money from Google actually posted a nice blog post earlier this year covering this problem. Can we install node modules from files located somewhere on the disk locally? And it goes through, there are some ideas, there are some explanations why it doesn't work. And there are also explanations what could be done instead. But the bottom line is NPM client actually needs a server to respond to you. Because NPM goes to the server and asks, did this dependency update by any chance? Oh, it didn't, so all right, I'll take something from cache. But it still needs to go to the server. So when we were faced with the rage of the version control team, we were forced or asked politely to find another solution. And there is the most logical next way. Just don't store node modules in the version control. Store it somewhere else. Let's look at the example. We have some basic project that goes to GitHub, but node modules doesn't go there. It goes to a network storage or a Dropbox folder or somewhere else. Whenever you change a package JSON that represents your modules, you zip your node modules and send it to the network and associate it with your package JSON, probably by the hash of the whole file. Whenever your teammates are rebasing on master branch and they see the new package JSON, our tools go to the network and get the same zip file that you uploaded before. And this should work quite nicely, right? Well, not exactly. The thing is that version control systems are for team collaboration. But the network storage is not for collaboration. For example, I can change a file and my teammate can do the same. And GitHub will automatically merge the changes if there are no conflicts on the same lines. A more concrete example, I change one dependency in package.json. My teammate changes roughly at the same time package.json, another dependency. And both of us upload the zip files to the network storage. When it gets resolved into the master branch after both of us merge it, we have a nice resolved package.json file in GitHub. But we cannot three-way merge two zip files, which are binary. At least it doesn't happen automatically. So there are two problems. First of all, we cannot do this three-way merge for something that is a binary. And second thing, it doesn't work really offline, at least how it works at Facebook. The trick about Facebook is that we have offices in London, in other areas in America and in Asia, and people travel quite a lot. At least 2 times a year, people travel between offices. And we spend quite a considerable time in the plane, where you don't always have internet. And when you check out a branch in Git or Mercurial, you have it cached, and you can switch between features quite easily. But if you don't have access to the network where your zip files are connected, you cannot run the application, you cannot compile it. And well, we were thinking, so this thing sort of works for us, but it could work better. Should we invest a little bit more time into making this network thing cacheable? Or maybe resolving this three-way merge thing, maybe automating it somehow? Well, let's make one step back. Let's look at how NPM works and how much work it will be to improve this third solution, because it works, but not completely for us, and it is a considerable investment. Let's see how NPM client actually works. Is it that complex? Is it hard? So we have our application A with the dependency graph. We have its package.json. Then we resolve all the dependencies and download them from the registry. We unzip them and place them in the folders. Is it really harder than the solution that I was explaining with loading something in the remote folder? Doesn't sound that hard. Well, full disclosure, it's actually quite hard, but not that hard. And another thing that motivated us while we were investigating the problem, there was a big change in NPM 2 migrated to NPM 3. A lot of engineers at Facebook didn't want to update to latest node version because NPM 3 became much slower. The thing is, they optimized how much files are extracted in the folder. For example, you have dependency C installed many times, the same version, deep in the trees. You can optimize it and have C installed only one time, and then there is a way to link to this one-time installed thing. So when they optimized it, they sacrificed performance of installing quite significantly. Here is an example. We have a network waterfall of installing the package with NPM 2. At the top is NPM 2, and it's many packages stacked quite nicely together. They just go and download. There is not much spacing between them. And here is what happened after NPM 3 got updated. We see a lot of white space between that. And you probably don't see the timing. NPM 2 installed this package in 12 seconds. NPM 3 in 50 seconds. It was quite noticeable to people. And while we were thinking about this, we started hacking. That's what people do at Facebook, trying to find a solution that works. And this is how Yarn was born. So Yarn is basically a reverse-engineered client to NPM. Nothing to it. So the work started at Facebook London office. And then once we saw some potential, people from other companies joined, from tldr, from Google, from Exponent. They offered help and offered to create a community project rather than belonging to some one company. So right now it is actually managed by the open source community, although big companies are involved helping and providing the engineer strength there. And after Yarn was released, just 2 weeks after that, we have 87 people who contributed code to the project. We have plenty of issues, but we're on the track of resolving them and finding out what can be done better. So when Yarn was designed, we put a constraints on us. We said that we must be faster than current situation with NPM. And also we have this pain of node modules management inside Facebook that I just explained you. It must be reliable, it must not, there must be a solution to not depend on network, and also we must protect ourselves from malicious packages. So let's talk about speed. Here is how Yarn works versus NPM 3. This is the timing of installing React Native, which is very topical to me. Red is NPM times, blue is Yarn. And it varies, depends on whether you have caches locally or whether you have a log file already generated. Most of the time, Yarn works just faster. Another important thing is you don't need to willfully generate shrink wrap. Yarn generates it for you, and Yarn manages it better. Here is an example. Here is the same shrink wrap that I showed you before, but in Yarn. The difference is that we decided to go away from JSON format because we noticed that people actually review those files. We need them to be editable and understandable by people. And another interesting piece is that we add a checksum to all the packages after they are installed. So if you installed something on your dev machine the first time, and then you test something in production and you want to install it again, you are quite sure that no one mangled with the file that is downloaded somewhere from the internet. And of course, the question that I asked before, can NPM work with files local, for example, if they are checked in? The answer is, of course, that's the idea of Yarn. That's why we wanted it. We wanted to be hackable. And here is an example. Remember the pull request that I showed you in the beginning, where we had 208 files? This is the same change, 0.6 to 0.7. What actually changed is 3 targzip files that got downloaded. I checked them into the repository. Then a package.json changed. And then I review the yarn log file, because I care what changed and I want to know what happened. A new dependency got added with the SHA-1 in it and the location local to the folder. Another one added, and then another thing replaced. Easy to review and easy to three-way merge. And here is the summary. NPM is quite amazing. It works quite well for the community. But it is very easy to mismanage node modules with the current tools we have. That is why Yarn was created, and that's why we think it's useful for the community. But this journey is not finished. We just started, and there are many things ahead of us that we want to sort out for JavaScript dependency management. That's all.
Hi, really nice talk, thank you. Isn't it better to restrict the number of people who can modify node modules and their dependency to have like a node package manager who will be deciding when to what in requests by other developers, and to have 1 or 2 people or like 5, but not like every developer to be able to change the packages, but to have like, you know what I mean?
No, exactly.
Because probably in Facebook every developer can change the packages and the dependencies. Maybe it's better to do it on request by some people who is on top, and then to have like a more stable node modules than to change it like 100 times a day, right?
That works, but doesn't work at Facebook's scale. At Facebook, we have 1,000 commits happening a day, and it's just impossible to have one person owning a piece, because people need sub-dependencies, people need to be unblocked, and they work across the globe. So the person responsible for generating node models could be fast asleep, while the other person needs to fix a bug. That's one concern, and the other one. Yeah, I guess we could dedicate 1 or 2 or 3 people, but we would rather fix the tool rather than rely on people not making mistakes. For smaller teams, yeah, it can work. Whatever works for you, actually. It's a voluntary thing, and it's something that everyone should check for themselves, something that they should evaluate the risks and the gains and the losses. So yeah, whatever works. 1 person is quite fine, as long as, here is the situation we had. We had a CI server running Linux, and most of the developers run in Mac. If that person who generates node modules, and if he or she checks in those node modules or sends them to a third-party storage, they are basically Mac-generated C dependencies. And then if a Linux server tries to run it, it will fail. So there are extra tools needed to provide for the cross-platform thing.
When you have, I heard that you on Facebook there's a single repository, right, for everything.
Yes.
And now when you have a single repository and commit lots of binary files into it, how do you handle that? At some point, my local clone would be just too big. How are the strategies for that?
Well, here is an example. When we were committing, so the question is, what happens if the files that we commit, for example, for React Native, the targzip sources of packages into the source control, what happens when it becomes too big? First of all, we need to understand the scale of the problem. When we were checking in node modules as they are installed into the repository, we were checking in 150, 200 megabytes and 100,000 files. Right now, we're checking in 800 files, 100 times less, and 20 megabytes total. So those 20 megabytes gets unzipped into 200 megabytes. So we have quite a little bit of breathing space here. Another trick we actually have a common storage for all the offline things. For example, React Native and Nuclide projects, they share roughly 50% of dependencies. So this common storage that we have in one large repo is reused quite a lot. Adding a new project in the same system is just adding a few targzip files that are not yet mentioned. But again, this will come. At some point, there will be a problem. Like if we have a large JavaScript base of a lot of applications and they are drastically different and something grows. That's why I ended my slide that it's 1% finished. Once we get to the scale, we get new problems and we will find new ways to solve it.
So what should we do? We should use Yarn or should we commit our node modules to repository? Now.
I would personally, outside of Facebook infrastructure, I would use Yarn and check in the targzip files, the sources of the packages. And that would use Yarn to rebuild the packages when I need a fresh node modules. This is quite fast and doesn't take too much space, but it all depends. People actually use node modules and NPM right now for other languages like OCaml, Reason, C++, Java, whatever goes into the registry. So some of the dependencies could be large. Sometimes it could be 50 megabytes per file. So you have to use your judgment.
And just getting back to the scale of your project, are you able to review your code if you have in the team like 100 commits per day? Are you doing code reviews?
Yeah, of course. No one actually should be landing changes without someone else approving it. In very rare situation when something is completely broken, you could go through this, but we trust the engineers to use their best judgment not to do that. People at Facebook, even though we make 1,000 commits a day, but we don't change the packages 100 times a day. People are quite familiar with what packages.json does, so we don't need one person to review that. Teammates, as long as they are all working on the project and as long as they can explain why they are making change, others can sign off on it quite well. And with continuous integration and with builds running all the time for every commit we make, we can ensure that people don't break each other's code. So the answer to scale is continuous integration, tests, tests, tests.